Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. This is episode 26, where we will be continuing our streak from last time, trying to get these last games to run. In this case, we're working on not Red Alarm, even though that's what I'm playing, or at least that's what I'm letting play. We'll be working on Space Squash. Now, I actually, it's been a few weeks since I streamed last with emulator stuff. Took some time off for focusing on revision stuff. That's been really, really fun. We did an awesome intro that I'm extremely happy with, but now it's time to get back on streaming and stuff. So streamed some other things, like we started doing the demo scene streams again. So I was able to stream a breakdown stream of our last intro, which is really cool. Also started live coding some stuff. Now it's time to get back on some emulator stuff as well. I'm pretty excited to do so. However, I have not had that much of a chance to get caught up on where we left off. So I'll be bumbling around a bit in the beginning of this, but I think that'll be okay. Watched a bit of the end of the last stream. That's the advantage of having all that recorded. And kind of got an idea of where we were, but as far as I know, we're basically reverse engineering the startup routine for Space Squash to see why it doesn't actually start. And probably gonna just have to sit here reverse engineering some code. Maybe that'll take a few weeks, I don't know. We'll get there eventually. But I think it'll be pretty fun. Anyway, glad to be back. Hi to guys in the chat, Try Later, Creekpot, The Iron Flame, Dom170. See a couple new names in there, happy about that. Welcome guys. D-Bozan, Mad Moose, DK, Dano Collin, Dark Second. Good to see you guys again. Mad Moose, whoa, it's like he's communicating through video. Yeah, I messed up on the time zone here, so I added a little thing. It's okay. It's okay to put gaffer tape all over your stream. It's actually been a while since I ran this as well. It's been about a month. And it's actually really motivating to actually see this running, especially a game that's this complex. Unfortunately, it doesn't run all the games, but this is pretty awesome. Yeah, Colin, I'm new. What's all this about? I'm guessing you're asking if I'm trying to stall the stream. Actually, because this is running, you can tell that my Rust did update. So I did a Rust update like a half an hour ago. It actually took quite a while. It took like 20 minutes. Probably because I was using bandwidth for other things as well. Anyway, finally finished right before the stream, but Daniel, Colin, and I were joking that I would have to drag this out. I actually considered going on his Twitter and finding pictures of his cat. Just as something to show. Thought that'd be funny. Evil, how's it going? But for those of you guys that are new, we're building a Virtual Boy emulator. I haven't been streaming the entire process, but I'm streaming at least once a week, so I'm at least streaming regularly, except for the last couple weeks because of the revision stuff. But I usually announce that on my Patreon. That's pretty cool. Michael C, how's it going? Got 170, almost done. Nice. Ready for summer, I guess. Yeah, it's like there's sunlight in my apartment. I don't know if you guys can tell, but it's really nice. Starting to be light when I actually start these streams. Michael C, nice looking game. It really is, actually. I mean, not as nice as some Polygon stuff might have been, but it does have wireframe, and it actually has different tones for the like different shades for the lines as well. So it has some depth shading here that's pretty cool. I like this too. They made parts of the tunnel like darker, but then they made the boss really, really bright. That's pretty rad. Tupos and sunlight, what's that? I'd have a hard time explaining. Mostly because I don't really know what it is myself. I'm not trying to stall, by the way, you guys. I'm just sitting here hanging out, looking at this thing. Evil 3D wireframe the best? Did I already read that? I probably did. It's a pretty cool game. Actually, these little intros here, these animations, there's like 4 or 5 of them. They change every time. It's pretty cool. They also seem to be different every time I run this, which is a little weird. That shouldn't be the case, but maybe that's just in my head. Evil, do you actually have 3D glasses for this? I actually don't. But if it is cool, that's awesome. Hey, so the design, how's it going? We should probably get started here pretty soon, but it's just so fun to watch this again. Actually, I should have let Space Squash run here because I have a couple hacks from last time that should actually allow it to run. Ah, cool, Dana Colin. Congrats on your SDT SNES. So it has a USB port, but as far as I know, that the FPGA firmware doesn't actually use it. But I think it's there for like future use, and I'm pretty sure that stuff is open source. I don't know how to flash it though, but I've thought about looking into that. It's pretty cool. H. Cryan, yeah, awesome. Hope it looks cool. Michael C212, how many instructions does the NEC V810 have? I can't remember. Not that many. We can actually look at the code here. So basically all the instructions minus a couple that are related to the cache are implemented in this case. We've already gotten through a lot of those. I'm just going to eyeball this, not actually count these. So let's say this is like 6. I don't know, like 50. That's probably a high-end estimation. Armageddon's Witness, thanks for the follow. H. Crying got my 3D from random 3D children's book. Yeah, I need to just order some. Yeah, Dino Colin, that's why I also have the EverDrive. The SDT is way better for like playing games because it's faster to flash and everything, and also it's yeah, faster to flash, faster to load. I found it also seems to be a lot easier with like save management, and then of course it emulates some of the special hardware. So, but the EverDrive, just because it has the working USB port and command line loader, is just awesome for development. I have like these speakers here, and they have enough room on top of them that I can like put old systems. It's actually like the perfect size to fit a SNES. Although I've got a N64 up here right now. We can pull that over. Yeah, my N64 on the left, and my sound card actually on the right. So design, I got mine from the Rust Boy book. What a coincidence. That's funny. Yeah, I really need to pick up a pair. For a while, I had this backwards. The red and the green. Studio C, how's it going? Man, it's cool to see all you guys back again. Anyway, so this is the game that we're actually trying to get to boot. Which sounds silly because you can see here it's running. But basically, I have this situation where if we set up the hardware to an initial state that we expect the hardware to be in, and we've done hardware tests to make sure that we know what the hardware state is going to be, there's this one particular hardware state, which is whether or not the display is enabled. So the hardware has like these two major states. It has drawing it has this drawing feature, and it has this display feature. Drawing is about taking some data that are in these tables in memory and then expanding graphics using those data out into the frame buffers. Display is about taking what's in the frame buffers and then passing them to the scanners that scan across your eye and give the 3D effect. Basically, on startup, the display is supposed to be disabled. However, with that configuration, this game doesn't seem to boot. If I make that state enabled on startup in the emulator, the game boots just fine. And I looked at a couple other emulators like Mendafin. Mendafin has that state as enabled by default. And that's not correct because we know that from hardware tests. But somehow this game doesn't end up booting. Really not sure why that is. Sorry about that sort of design. I need to add you to my regulars. I have links disabled. But you're here all the time, so sorry about that. Like, so yeah, it's a lot easier to implement in a lot of ways. I mean, it's a more complicated CPU, like it does more, so you'll have more kinds of features. And like the 6502, or in that case, is it the 2A04 or something? Which is just 6502 or 6507 variant, I believe. A lot of those are the same things, but with like different register combinations. But this is RISC, so you just like read some bits and, oh, that's the register. Oh, this is the destination thing. So. But Moose made an x86 disassembler. So many instructions and many different encodings. Evilak, another bugged game. Emulator needs to fix it. Yeah. I could just patch the game code. Ah, that's cool. Sort of design. I'll still add you to the regulars thing. Just gotta click through some menus here. Cool, that should be fixed. 2A03, yeah, that's what it's called. Off by 1 errors. Every programmer has them, even when they're using Rust. Oh, I read the best quote. I can't remember who it was by, but it was someone was asking for someone to describe Rust's memory management in 2 words. And my favorite reply to that was, "Sorry, Dave," and then in parentheses, "I can't let you do that." And I just loved that. Because I thought it was accurate enough, and I just thought it was really clever. There were more accurate answers than that, I think, but that was my favorite. Can't remember where I saw that, but had to share. Yeah, so what we know is that there's this particular hardware state, and if I hack it, we can get the game to work. Otherwise, it doesn't work. Now, I set up last time basically a thing that would just disassemble, like dump disassembly as it's running everything. It's crying. You know, I'm actually gonna look that up really quick because it's that cool. Let me put up a game with awesome music. Like Waterworld has the coolest music. And a bunch of the other emulators appear to play this too slowly. The song is actually a lot faster than a lot of the recordings you'll find. Beautiful music. Armageddon's Witness, could you provide a link to the hardware FPGA board and IDE framework you're using? I'm not really sure what you mean by that, because if you're talking about this emulator, I'm not using an FPGA dev board for that. So I'm not really sure what you're referring to there. Dino Colin, did you finish figuring out the diff and sample playback stuff, by the way? So I didn't. There was a long thread that I still need to read with a couple guys going over the timer implementation, interrupts and doing some cycle counting. I got a flash cart myself, and I want to do some cycle timing on that, but it actually seems to be that the timing, in particular, like the amount of cycles it takes to enter an interrupt and some other timings actually appear to be significant. I really need to revisit that. So no, the answer to the question is no, I haven't figured that out yet. Yeah, gonna revisit that. I kind of don't want to work on that right now. I like to bounce back and forth between different parts of projects and stuff. And kind of want to break from just looking at that timer. Oh yeah, sorry, Armageddon's Witness. I have played around with some FPGA stuff. I used an Altera Max 10 FPGA development kit. And I mean, it was nice. I don't really understand, like, I don't have that much experience with a lot of this stuff. So it was just like kind of my first FPGA that I bought, and I'm really happy about it because it has a lot of the peripherals that I wanted, and that's why I ended up getting it. I can give you a link to that. And then I was just using Verilog. Hey, Alkama. Yeah, I need to find that that Rust thread. This Waterworld soundtrack is so good, though. All right, I got the thread here. There we go. Yeah, Eva, like I said, like I don't really know if that's like a particularly good dev board, but it had a lot of the stuff just on it already that I wanted to play with, like HDMI and some audio, or like at least some analog plugs. So I thought it would be a pretty good one to get started with. Little pricey, like I know you can get cheaper ones if you just want to play with that stuff, but I thought that would be pretty cool. So you just did a course a couple months about FPGA development, and it is super fun, even though it can be painful at times. We also used Altera. I really didn't like the vendor-specific tools that came with it. Like I ended up making a project in Rust to manage like the make my own project files as JSON, and then it would just generate whatever tools I needed to actually build the thing. That ended up being a lot nicer than the tools provided by the vendors, until you want to do like timing tests. But I didn't actually get that far in terms of the complexity of the stuff that I was playing with. At some point, I would love to do more of that stuff. A Snickerdoodle FPGA. I have not seen that. Oh, that's cool. A little ARM processor, FPGA, Wi-Fi, Bluetooth. That looks cool. And then just a bunch of ports. Yeah, that'd be cool. I've considered at some point I would really like to like build something where I could like make a GPU like that, or make some kind of thing like that. Like I really want to take the FPGA board and make a like a demo platform where you basically program like almost like 8-bit pixel shaders. So you have a bunch of 8-bit threads that'll do like the per pixel calculations to figure out like the pixel color paletted, of course. But yeah, it'll be kind of like an 8-bit instruction set, but you'll have it at a really high speed and at really high res. I think that'd be pretty cool. Well, that's cool sort of design. I'll have to hit you up sometime on Twitter or something, and then yeah. pick out some more boards to play with. Daniel Collin, just what LFT did. Yeah, LFT really inspired me with a lot of his stuff. So you see there's a project to take GBA to FPGA with perfect electronic accuracy, but this was a long time ago. Don't even remember the name. I would actually really like to also like make a board that could take the scanner output of the Virtual Boy and then like feed that to me via USB or something. Because I really want like sort of better ways to develop for these platforms. Yeah, the Amiga stuff is really cool. Why is everything so interesting? This is what I like about streaming. We can just hang out sometimes. Talk about cool stuff. Oh, this is the worst game. Okay, so yeah, so what I did is I went with Space Squash, and I I had it so that it would actually like dump the disassembly of everything it ran. It ran, excuse me. And then I ran it with this hardware state disabled how it should be, and then enabled how it shouldn't be, and then basically diffed those in a text editor, so I can show you those. Those of you guys who missed that, but also for a refresher for me. So I made this dump disabled and dumped enabled.txt. And these are literally almost exactly the same until a certain point. Because I just literally ran these, I don't know for how long, and then diffed them. And at some point we found that they started to differ somewhere around here, and I can't remember if we started just disassembling from the beginning or if we found this later. But what I'm going to do for now is just to go back to the entry point and just kind of dig our way back in here and kind of start to map out, try and figure out what some of these startup routines are going to do, I think. Just to get an idea of what we're working with here, because this is where the code differs, but I don't know, like I want to have a better overview of what all the code in the startup routine is doing to figure out, like, is there something else that sets up a state that then this would obviously be expecting, like waiting for? I just don't know. So just need to reverse engineer a lot and figure that stuff out. Yeah, that's the guy, Studio C. His 256 byte C64 intro for revision was phenomenal. Called A Mind is Born, I believe, and it was so cool. Yeah, Daniel Collins already got the link. Recently, I was looking at some C64 stuff, and he also did some really cool work with the reverse engineering the VSP bugs in on C64. Figuring out why it happens, why it crashes, how it crashes, and ways you can work around that. Which is basically because there's some hardware bugs in the C64 that allow you to violate DRAM timings. And depending on your board and the capacitance of it at any given time, can crash your system or not. Oh, he does great work. Yeah, I think you're right, Susie. Evil, if you're looking for awesome VB games, Bound High is really fun. I actually really like Panic Bomber. Had some fun with Mario's Tennis. Red Alarm is like one of the more technical ones, and it's really cool to see it running in the emulator, but it's actually not that fun. Gets old pretty fast, I think. Tolero Boxer is really cool. Those would be my recommendations. Oh yeah, so what I was going to do is I was going to have this break when it starts up so that we actually can sort of step through stuff. Actually, we don't actually have to do that because I can just disassemble things. As long as we get this thing running, then I can break into the debugger. It's been a while since I used this debugger, so that'll be cool. Let me bump up my font size as well. I forgot to do that. There we go. Oh yeah, Debozen. Yeah, Wario Land is also really good. Mahoney research regarding the 64 is interesting too. Haven't seen that stuff. Although I have been reading a lot of forum posts by a guy named Matt Mahoney, but that's compression related. Different field. Not the Mahoney demo group. It's just, I'm assuming what that's referring to. All right, so how do I... Let's see if I remember this. We're going to disassemble FE 40. we're doing this. The errors here got huge after I replaced this parser, but they're actually, this parser is much better and builds a lot faster than the other one. Zokwar, is that one of the accelerator cards, or is that like a add-on dev card? Oh, so much cool stuff. So much interesting stuff. So I need to look at my commands here. It was in the CLI, I think. The command here, and I want to do disassemble, which was D still. I would have thought that that was correct. For the U size here, which is what that should have been. Oh, it's only taking digits here. So if I do like, you know what it is? I know what it is. This disassembles the amount of instructions. Totally forgot how to use this. No worries. So I think we need to go to there and then do it. I think that's what it was. Yeah, that's how you do it. Oh, it's a CPU replacement. That's cool. I definitely gotta check out that link soda design. Cool. Yeah. So we have something here. But was it F0 that was the reset vector? I gotta look this stuff up. This is what happens when I put down a project for a month. But we'll be back up and running pretty quick here, I think. The CPU will have the reset vector in the startup state. There's a bunch of stuff with the cache that I want to go over on one of these streams, by the way. Oh, just all F's and the 0 at the end. That makes sense, actually, because it's the last 16 bytes, and each one of these reset vectors has 16 bytes with which to basically set up a couple registers and then jump into something. I think FE40 is the display interrupt. I think that's what we saw here. FE10 is the timer, if I remember correctly. So if I do 16 here, it actually wrapped around here, but that's fine. Yeah, so this is going to be our entry point here. And let's see what if you look at this jump disabled, yeah, it's exactly where it jumps to. Now the startup here is actually quite a bit of ways away from that by the time they actually diverge, but I want to see basically everything it does is starting to set stuff up, because I think that'll be good. Oh, that's cool. SID chip is rad. Very interesting sound chip. Thanks for the info. Appreciate it. Back to the Rust. Okay, so let's go to here to start disassembling stuff. So this we should see exactly what this shows, basically what these dumps show here once we've disassembled this, which that is absolutely correct. We see these exact same instructions here. Yeah, Colin, so when the game starts, does it get stuck waiting for the display to turn on? So let me go ahead and run that. I'll reset that hardware state, and then we can I can show you. If I recall correctly, it sits there in a waiting loop, and it waits for a certain interrupt. And the fact that the display is enabled on startup enables an interrupt to happen, which I believe is the start of display processing. And I think that's what we looked at last time to make sure that that was the case. That's what it was waiting for. I think that's what it checks here. And then once it gets that interrupts, then it can actually move on. But Scorpion Illuminati, what is the Virtual Boy copy protection? As far as I know, there isn't any. Just straight up ROM. It's not region locked either, so that's cool. No, I was going to the VIP here, and yeah, it was the display enable here. Let that build. Scorpion Illuminati, nothing. Nothing prevents non-licensed developers from creating their own carts. Except, like there's a proprietary connector that it uses. And I guess there's some licensing details about that, but I'm not really sure. There's no technical copy protection, if I remember correctly. I mean, I definitely don't remember implementing anything, at least. Yeah, they had a pretty tough time actually getting any developers to make software for the thing in the first place. Anyway, so this is running. It's stuck in some loop, so we can break into the bugger here, and I believe that if we step through here, we just see it hits the same instructions over and over again. This goes to 9.7 here, so it takes with 0.500 here. Load high, hit an R1 here. Yeah, so it goes, reads this with an offset of 8 into R11, compares R11 to R10, and then branches if they are the same to this value here. So if we print out the registers, we're reading 0 here. Now, if I remember correctly, so like if we continue, for example, and then hit this again, we'll get the same instructions here. Whoops, that didn't look very good. Yeah, if I remember correctly, it was waiting. It just sits there in that loop, and then it waits for an interrupt, and then the interrupt actually, because that 0500 whatever region, I believe that's RAM. I'll check my memory map again. Believe that, yeah, that's RAM. And nothing's going to set that other than actual program code, so I'm pretty sure something in the interrupts ends up setting that. But if that interrupt is allowed to fire, then it actually goes. Scorpion, nope. There's no hardware for copy protection in the system. Which is a bit surprising given the era, but it's not surprising given how rushed the thing was to market. Yeah, because if this is literally just checking to see if something, yeah, it loads an address into R1. It takes the 8 bytes above that. So, for example, we could do a mem dump here. And the 8th byte would be this one. And it's just sitting here checking while that's equal to R11. Or sorry, while that's equal to R10. It'll just sit there in this loop. Something else would have to break it out of that. I can't actually put values into memory. As far as I know, when I debugged this, I think I was printing out the state of the hardware and whether or not that would fire. And I can't remember how I figured out that was what the problem was that interrupt would be able to fire. I think it was just that I was looking at what the last values that were written to the hardware states, and the interrupt mask that it wrote, I think, is what I was judging that from when I debugged this last time. So you knew what interrupts could fire, and the display enabled would have made that particular interrupt fire. But it never explicitly enables the display, but the display has to be enabled for this one interrupt to fire, which seems really strange. And from a hardware test, we know that at least on startup, it's not enabled. Honestly, though, I wonder if there's any condition where the hardware could enable that after some time. So one of the things I suspected is that one of the things that we don't implement is that the hardware actually takes a while for the mirrors to spin up. Like they start out of sync, and they won't turn on until there's hardware sync between the two eye scanners. Otherwise, it makes you feel really pukey. And so one of the things that I tried implementing was just some delay that's like 10 seconds, because sometimes it can take up to that long in the real system, where after that period of time, then it would enable the display hardware, and it wouldn't before that. And I thought maybe that would be relevant, but it didn't seem to actually make any difference. However, it is somewhat possible, I think, that after those scanners became ready, that it might enable the hardware if it wasn't enabled already. I wouldn't think that would be the case, but I'm just trying to think, like, maybe that's a possibility. Something I could actually test on the hardware. But I have yet to set up a development environment for that, so I'm not sure how tedious that would be. Atmospheric, where does one even begin when starting a project like this? The ROM? Yeah, you'll get a hold of some ROMs, and then start looking up the hardware. In this case, there's a website called Planet VB, and they have a lot of documentation on how the system kind of works. It's an off-the-shelf CPU, and then it has a bunch of interesting like video hardware. And if you can dig around and find like old development manuals and stuff, you'll find a lot of information about how this works. And based on that, and then disassembling the ROM, you can basically figure out a lot of stuff. In particular, when implementing this project, the first things that I did was implemented enough of the memory mapping for the CPU to be able to fetch instructions. And then while I was implementing each instruction, I would run the CPU as far as it could go, which initially it couldn't do anything. But it would give you like you'd know where it was running from. And then it'd be like, oh, I hit this one instruction, so let's implement that. And at the same time, I was implementing this little debugger interface that you can see here. So I kind of did that in parallel, so I could always like disassemble what would come next and then be able to run that. And doing that in parallel is a really nice way to sort of make progress and kind of sanity check everything as you're doing it, because you can actually see what the system expected to run, and you can look at the disassembled code and be like, oh yeah, this actually makes sense. Like even stuff like you'll run into an instruction that uses the wrong register, and then you'll know, oh, my register decoding for that instruction is probably wrong. So cases like that are really easy to catch if you do it this way. But yeah, I spent a bit of time, of course, reading about the system from manuals, and also like a bunch of documentation that the community has made from reverse engineering the system. So you can start from a lot of places, but that's generally a pretty good place to do it, I think. And a pretty common place to do it as well. It's different, of course, if the system is like really obscure, but manuals were made for these things at some point, so getting a hold of those really helps. You know, actually, let's try something here. This is just kind of a shot in the dark rather than some guided reverse engineering, which that's kind of what I should be doing, I think. other than making hardware tests at this point. But I think I can get pretty far with reverse engineering here. But I think I kind of want to try that if there's some weird hardware behavior where after the so basically you can get an interrupt for when the display is ready, like ready to be used. And I wonder if it's possible that could enable the display when that got ready. This is so the CPU in the Virtual Boy is a pretty obscure one. By the way, I'm responding to Atmospheric's question: was GDB not useful for debugging or not good enough? It's actually more that I don't think GDB supports this processor, and it's like my own emulator, so it's like I would have to add GDB support specifically, and then I just felt it was more straightforward to just write my own little interface here, just with basic input-output. So now it's at the point where hooking it up to existing debuggers could make a lot of sense. But the other thing is I'm not that familiar with GDB, at least not using it directly. But yeah, the CPU here is a V810, and it's a pretty run-of-the-mill MIPS processor for the mid 80s. But I would definitely, if you wanted to do an emulator, I would definitely recommend like building a debugging interface like that as you're doing the CPU, because it's so nice to have now, and it's one of those things that would be kind of annoying and tedious and like harder to do later, but doing it up front while you're doing that stuff is just super helpful. And I also just found it really motivating because you could just poke around in the machine, except you can't poke memory values like Daniel Collins suggested. Haven't added that yet. Yeah, it's unlikely that LLDB would also it's also unlikely that LLDB would support the CPU. It's a weird one. It's a weird one. Or at least I should rather say it's an obscure one, because it's actually not that weird. Like it is, like I said, it's pretty bog standard MIPS in terms of like the features that it has and how it works, and the pipelining and the cache and stuff. So it's yeah. By the way, this book has so much info on how a lot of that stuff works. Not specifically for that processor, of course, but like how the pipelines in that classic MIPS architecture works, how the caches for these systems will work. A lot of good stuff in there. That's Computer Architecture, A Quantitative Approach. This is the 5th edition. Awesome book. Yeah, I've literally just been reading it like kind of cover to cover style, just because there's so much interesting stuff in there. One of the things that I often don't think about when thinking about CPU design is the whole like I never think about the cost side of things. I never think about this was designed to make use of like to have this kind of throughput for this kind of clock speeds, and then all be built within this kind of process and this kind of cost. And I never think about that side of things. Because I'm usually thinking about it kind of from a demo senior's perspective, where it's just like, okay, how fast is it? What can it do? What can I make it do as a programmer? So it's kind of interesting to read a lot about that as well, because it's as someone who would design CPUs, that's obviously a lot of concerns that you would have to have in addition to the technical concerns, which is what I'm interested in. So it's really fascinating to read that side and all the technical stuff, especially the lower level cache details. That's actually what made me get it. It turns out stuff's really simple down there. Even for like an i7 cache, it's a lot simpler than I would have realized. But just knowing how that stuff works and seeing it in a diagram is really nice. Yeah, Daniel Collin, exactly. This is slow. The CPU sucks. I actually think Virtual Boy would be a really fun system to make a demo for. So sometime I got to do that. But So yeah. So what I was thinking about just now was that I had it set up. I was gonna try and simulate like after the displays are ready, then maybe I could enable the display and see like if that worked, like to have a delay period. I think actually I have that on a branch. So let me check something here, because I can always just stash what I have here. Yeah. I totally do have this stuff in a branch called Startup Display Stabilization, so that's nice. And then we should have some states here where it's simulating that that delay when it's doing the display stuff. Yeah, here I have display stabilization period. And at some point, let me see where this is used. Yeah, so we add another state here. It's basically if is display stable. And if it's not, we're doing this. And eventually, it just is literally this clock counter that delays. Eventually, it'll set this. And I'm just wondering. Yeah, so by the way, if I just run this, I don't think it helps. Just run that again, just in case. But that basically shouldn't help, if I remember correctly. So that was just one of the things I suspected. Didn't work. And then what I'm thinking, though, is that maybe this enables the display as well. A quick hardware test would help there, but again, I don't have the environment set up, so maybe I'll have to do that later. Yeah, so this doesn't help, and if we break, we're at the same instructions we saw earlier. So that doesn't help. But was it? If it's somehow enabled the display on its own, would that work? Like, just let's hypothesize this, because it's something I haven't tried. It'd be really funny if that were actually the issue. It would save us a lot of reverse engineering. Okay, so if that were the case, the game does boot. It would appear. So that's actually interesting to know. I'm going to add that to my notes. By the way, I have this on GitHub on the Rustral Boy repo, which I think if you do bang repo in the chat, I think you'll get that. Yeah, perfect. I have this Road to 1.0 ticket here. And it's basically all the stuff I'm thinking to get to like a 1.0 status for this project. And the bigger ones here are that I want to do libretro as a primary front end. So we'll do some work on that later. Finish up some stuff on the CLI front end, in particular stability with Mac. And then the one that I'm most interested in right now is this 100% game compatibility. Now, we fixed vertical force. We fixed some bitstring stuff, which literally fixed 4 games, or at least got them working to some degree. Nestor's Funky Bowling still has some other issues, but there's something else there. Anyway, Space Squash is what we're working on. And so I'm just using this to kind of collect those ideas, what we want to do for the 1.0. And I'm also using this to take some notes here as well. So I'm just going to add that to those notes. I like to do this stuff as these big checkboxes, because I find that really easy to get like full overview of when you're reading it. Even if I'm stuffing a lot of extra notes in here, I just think that's helpful. Yeah, here's the note about how that didn't work and why I stuffed this on a branch. So that's pretty cool. That's cool to hear, Daniel Cullen. I just find it's so easy to like get, like if I don't write all this stuff down, then I think about it all the time. It's so nice to just get it out of my head and just be able to get overview. It's like basically the only reason I can sleep at night. So if I remember correctly, the particular interrupt that it waits for basically has to not fire when the display is disabled, because at one point I did a bunch of debugging. So one of the cool things that I made on the RushToolBoy thing that I'm really happy about is I did a little blog. If you go to rushtoolboy.com, made a little blog here. And the nice part about this is that I've been documenting a lot of the bug fixes, at least when there's a lot of interesting ones. And the first one I documented was this Mario Tennis bug. And the issue is that when it would switch screens from like the menus into like the in-game stuff, every so often it would just corrupt a lot of graphics, and the graphics would like stay corrupted in the same way the entire time the next screen would be displayed. So I knew it had to do something with the transition and not something that was wrong with the screen itself. Otherwise it would change over time. But it only changed when it would switch screens. So I ended up doing a lot of debugging, and it turns out that during the graphics decompression routine, an interrupt would fire, and that interrupt wouldn't preserve all of the registers that it used. So it would end up clobbering registers in the middle of this decompression routine, and then the decompression routine would, of course, corrupt all the data because all the registers were different values than what I would have expected. Really fun to do that, because like I reverse engineered the decompression routine for this to actually figure out, where it was breaking, and ended up like rewriting that in Rust, and that was really fun. But anyway, the code for this, what it would basically do is it would disable the display and then run the graphics decompression and then re-enable the display. And so this particular interrupt is the same start of display processing interrupt that this Space Wash game is waiting for. So in order for Mario Tennis to work properly, when the display has been disabled, that interrupt cannot fire while the display is enabled until the display is enabled again, and then it's allowed to fire. So the logic there is that this interrupt does not fire unless the display is enabled. However, the weird thing about Space Squash is that it doesn't enable the display explicitly. It never writes that particular bit into that register that says that the display should be enabled. Yet it expects that that interrupt to fire, and that's the weird part here. So that's why I was thinking to reverse engineer a lot of the startup code to see, okay, what registers is it writing? What's it trying to do here? Is there any logic that it skips over that we missed? So I'm just really not sure. Soul Reaper GZ, sorry about that. I have links disabled. If you whisper it to me, I can screen it and check it out. Yeah, Scorpion, exactly. It's clobbering time. Anyway, that was a really fun debugging experience, even though it was very tiring. So something similar is happening, but it's very interesting, actually, that this could cause it to work. Actually, I want to do a quick skim of the docs just to continue going on this tangent. Let's see if there's anything like that here. So one of the documents I refer to a lot is this sacred text scroll here. It's available on Planet VB. I'll just post a link here. It's an unofficial document, but it covers a lot of this stuff. It's pretty good. Display registers. Yeah, it has this begin of the display process procedure here. This is the interrupt in particular that's firing. Devo said Nintendo still has tech support articles for VB on their website. That's awesome. I didn't know that. You should whisper me that link. I would love to check that out. That's awesome. Yeah, so basically there's this display status register that can tell you what the display is doing. Basically if it's enabled, which is this one. If it's ready, which is the thing that is actually delayed on the real hardware, because that's whether or not the display things are in sync. And then like if the different frame buffers are being displayed, so you have the left eye and the right eye, and then you have 2 frame buffers for each, so that's why there's 4 bits here. And then also if it's doing a memory refresh for the DRAM for the not the frame buffers, but the tables that this other stuff is in. And yeah, if the display sync signals are enabled, just another thing, and some other fancy stuff. And then, so this is the thing, is that if I remember correctly, Space Squash never enables the display here, but then expects an interrupt to fire when this is happening. That's kind of the issue. More tangents. Got to check out these support articles. Oh, that's so cool. Assembling your Virtual Boy for the first time. System no longer working. Gotta check these out. This is awesome. Get some manuals. Where to buy. Oh, that's just general Nintendo products. Not interested. Assemble. Here we go. Press your face into the eye shade. And adjust the angle of the Virtual Boy by loosening the knob at the top right of the stand. When you find a comfortable position, tighten the knob to hold the Virtual Boy in place. Oh, that's great. Follow the instructions on setting IPD in focus. Oh, yeah. I know this picture. Where is it? Come on. There we go. Initial startup screen. Yeah, every game seems to have this. It's supposed to be a calibration scheme as it's showing here. Go to the EPD dial until you see all of them, and then focus until this graphic is clear. Awesome. Yeah, theirs is a bit impressionist. Awesome. What a cool find. I love seeing this stuff. It's so funny. Yeah, thanks for sharing. That's awesome. Yeah, so what it does do is it enables the interrupt, in particular for the startup frame processing. So it enables this, but it doesn't enable the display itself. And I'm also fairly certain, if I look at the logic here, just want to see where it raises that interrupt. So in this case, it'll do it if the display is enabled and we have the sync enable. Trying to remember where it raises that interrupt. Oh, I think it's in here, actually. It might be. No, because this is just the actual display routine where it actually makes the pixels out of that. It's normally supposed to scan out to the scanners, but I just have it set up a little bit differently for convenience. Move away. How easy would it be to get Rush Boy on Android? It'd be really cool to do Google Daydream. I honestly don't know. So we've done everything to split up the Rush Boy into a few different projects. In particular, there's Rush Boy Core, Rush Boy middleware and Rush Boy CLI, and core. Core and middleware at least should be able to be built for like any target because they don't actually do any IO. So you would have to do some bootstrapping work, but it should actually be like as easy as getting any other Rust project to run on there. I'm guessing you could expose it as a C API and then just link that into some other Android project. I know that one of my colleagues did that with one of his emulators for one of our company hackathons. So it should work with this one as well. But I haven't actually done that process myself, so there should be nothing stopping someone from doing that. I don't think someone would run into too many surprises if they wanted to do that. Pardon, it's just J and IRS. I don't think you'd even need that because you can just expose a C API from Rust. So would have to do that thing or that bit of software by hand, but that wouldn't be too bad. Wait, 00, yeah, I know that feeling. Maybe on the next company hackathon I'll do that. What was I looking for? Yeah, interrupt pending this one. I was looking for this. Where does it raise this interrupts here? Oh yeah, here on the frame clock. That makes sense. Yeah, so here, if the display is enabled, then we'll have the interrupt pending, and then we won't actually raise the interrupt unless the interrupt is enabled for this. So that's how the interrupts on the system work, is that if a condition happens that would trigger an interrupt, you'll get a bit set in this interrupt pending register. But then unless that bit is also set in the interrupt enable register, you won't actually get a CPU interrupt. You'll just be able to check that thing actually happened. So yeah, so the if I remember correctly, Mario Tennis, it doesn't disable the interrupt enable for the start of display frame. It just disables the display. So like this logic has to be this way for that to work, if I remember correctly. So it's the way to revert that, by the way. Let me switch branches here again. So we're back on master. And then what I was gonna do is I was gonna break Mario Tennis again. Just to show the contradictions here. I know we're moving a little slow today, but I gotta kind of reacquaint myself with the project as well, to kind of go through this stuff again. And it's kind of better if everyone sees the problems here as well, I think, to get more context. Should still be pretty interesting. Yeah, so the start of the display process frame clock here. Yeah, so if this were able to fire even when the display is disabled, the logic to do that would be this. Yeah. And if I recall correctly, this will make Space Squash work, just allowing this interrupt that it expects to fire when the display is disabled. Which also, to me, says that when that fires, it somehow enables the display as well at some point. So it enables the display when that interrupt fires, which is interesting. Yeah, but then if we run Mario Tennis, that's what it's gonna do. That's what it's gonna do. Ah, emulators are cool. So this will work fine. But if I go into like the next screen, for example, see how there's just a ton of graphics corrupted? And if I go back, which I don't remember which button it is. It's not that button. There we go. Now this is corrupted. And some of Mario's graphics are corrupted. So this shows that interrupt wasn't supposed to fire in this case. And I'm fairly certain all it does is disable the display. Wait, 00. Now that's probably normal. Ship it. D-Boson, good old game of Mario 10. Yeah, that's actually what I named the the blog post. Anyone up for some 10 corruption? So that's why I concluded that this start of display frame interrupt is only able to fire when the display is enabled, because otherwise that would break Mario Tennis. And that makes sense, because the display process wouldn't start if the display were disabled anyway. And again, from other emulators, I know that they just have this startup state wrong. And that's why it works there. Which sucks, frankly. I am not comfortable with putting out an emulator with a bug like that, with something that we know is wrong. I think I've said this before, but there's like that's kind of where I draw the line. Like if it's something we don't really know about, but we make like an educated guess of what it could be, and we put that in the emulator, okay, that's fine. Or if it's something we can improve later, that's fine. But if it's something that we absolutely know is wrong, I don't want it in there, because that's not helpful. Yeah, I corrupted Mario. That's how I get around copyright. It's not Mario, it's Mario. Yeah. So here's broken Space Squash again. So I'm just kind of thinking, let me enable logging here to get us that'll make it easier to see what's going on here a bit. If I to do that, I believe it was, I always forget the syntax that we ended up with on here, which is fine. And we can just do log core all, so it's we have this feature gated so that we can only conditionally compile it like this. I think it's features like this, and then we put a bunch of these in here. In this case, it's log core all. Makes it really slow, but might show us some stuff. Cool to be back on this project again, even though I'm going a little bit slow. Yeah, so here we see, I'm just gonna break in the bugger here to stop this. Here we see what it's actually writing here. So at some point, here's what it does. So this is also particularly interesting, by the way. We are getting an exception here, FE40, which is going to be our display interrupt. So we get we see frame clock rising edge to game clock rising edge. We enter an exception. It reads, so something reads the interrupt enable register. So it's probably doing a read modify right here. And then it writes to the interrupt enable reg just 0. So it disables all the interrupts. And then it will enable these 2 bits here And if I recall correctly, all right, let me double check which ones those are. So that's enable start of display frame, and also the enable drawing finished. So it enables those interrupts, and then it only clears the drawing finished thing, which is kind of interesting. And then returns from the exception, and that whole thing happens again. And I'm fairly certain when I debugged here, because I can add a breakpoint to the display interrupt, so we can continue, and then we've hit that. This is why this debugger is so helpful. This does a bunch of stuff pushing things onto the stack with some awful ugly code. And then jumps to this routine, so we'll go ahead and go there. Might actually just step along that. Rather than typing the address, I'd rather hit enter a bunch of times. Bit silly. There. And then just jumps to this other routine here. That's kind of funny. And here, this 5F8 thing here. So these two things right here, these two stores. Actually, that's into R20. Where, yeah, here it does a load from R20 into R10, and then does some conversion stuff. I think actually 7029. That's actually here. Yeah, so it only differs when this interrupt actually fires. So that's actually what we're looking at here. That's kind of cool. That's what we were just assembling last time. So here we saw, this is the same code, by the way, just with my notes from last time. With some stuff commented out because there was like some, just storing some registers on the stack. And then, yeah, here we read the interrupt pending reg, which would tell us which interrupt actually triggered. Yeah, so that's the address of it. And then here we read it into R10, put R10 into R23, so then we have the value of this ANDed here. Is that what's happening here? Into R10, yeah, and then we AND this other offset here, and that's why we have this interrupt pending reg and the interrupt enable reg. So we mask out all the bits here if I still have some of that output from before we broke in the debugger. So basically reads this, whatever the interrupt enable reg was, or maybe I just don't print out the interrupt pending register writes or reads, because then it would make sense if it read from the interrupt pending one and then it read from the here would have been the interrupt enable, and that's what we see here. Masks those out, which would explain why if we wrote this back we would get 0. But I'm not sure if that writes it back there initially. Anyway, there's going to be some conditional here where it's going to check to see which, yeah, here we go. Check R10 is 0x10, and that 10 again was the start of display processing. So I think it was this conditional here that checks if that was the thing that caused the interrupt. Because that's how you check what actually caused the interrupt. Like you always go to this jump vector when, or this interrupt vector when a display interrupt happened, but then you check the interrupt pending register to see which interrupt actually happened. And it's this branch here. It checks it with these bits in particular and then diverges there. Oh, sorry, was I typing off screen? Sorry about that. If I was typing to switch branches, then that doesn't really matter, but sorry if I was typing stuff here that was off screen. T-Boson, yeah, I also think that left to right thing is kind of ugly. I'm also used to the right to left stuff. I mean, at this point, I've just read enough of it that doesn't make a difference anymore. But yeah, that's not the prettiest thing in the world. PowerPC mixes it, says Daniel Collin. Yeah. I lightly curse on the stream, but this is a really good opportunity to just say, fuck that. Because that's just stupid. That doesn't help anyone. $2 those monsters. Loads go in one direction, stores go in the other. Yeah, that sucks. That's really dumb. Wow, it's already been an hour and a half. This has been a really distracted stream. It's been a fun stream, though, so I appreciate that. But been a really distracted stream. Yeah, so actually, Dana Colin, I knew you've done some stuff for those kind of systems, but how often did you actually have to read disassembly? I guess you were doing a lot of optimization work for some of those, so then it would have been useful. But I would imagine at least you're doing a lot of that, and like you're doing most of the stuff at like the C++ kind of level, so you wouldn't have dug down that deep that often. But I guess if you're optimizing, and crash debugging, yeah, that's a good point. That's a good point. Ugh, fun times. Sounds brutal, man. I should have just programmed in Rust. Dan Collins sometimes looking at CodeGen also. LLVM at least has a PPC target. I don't remember if I think Rust has different tiers of like platforms they support. I know I don't think it's tier 1 at least. But I'd be surprised if there wasn't at least a way to build PowerPC code with Rust. Windows Zero solution never crash. Crisis Rust can target PPC. Yeah, I'd be surprised if it couldn't. So, I mean, the other thing about that tiered platform support is like it's not just the processor, of course. It's like the environment as well, like PowerPC Linux, for example. I don't know if that's actually a thing, but should be. Can it build 68K code? Nim can. That's interesting. Yeah, I think because it's 9:30, I don't know if I would go that much longer anyway, and I've been so distracted today. Again, not feeling bad about it. In a good mood. This is pretty fun, but I think I'm gonna not continue to dive in, and we'll hit this stuff again next week. May work on this during the weekend before then. Of course, if I find anything, I'll go over it, but probably be working on some other stuff this weekend. Oh yeah, I forgot Nim just compiles to C. That's funny. Demos ain't gotta have them Mac OS 7 demos. Awesome. Wait, 00. Yeah, I was waiting for that. Knew that one was coming. Steady hand to magnetized needle. I love it. Dubozan, you should do demos. Demos are really fun. Not on Mac, though. Not on classic Mac, but they're fun to do. Anyway, this was really fun, guys. Fun to be back on this project. But I think I'm going to shut things down for today, and we'll hit this again next week. So, thanks for hanging out. Thanks for joining, and I'll see you guys later.